Guys, let's move on to number 37. It says, what is the formula mass of copper 2 chloride? And it gives us the equation over here. Now remember that the formula mass is the same thing as the molar mass, except that it just has different units. So we're going to start off and work it exactly the same way. We're starting off, we have copper and we have chlorine. We're going to go ahead and we're going to see how many of each of them we have. We have 1 copper and we have 2 chlorines. We're going to multiply those guys by their atomic masses. And we find them on the periodic table. Copper is 63.55, chlorine is 35.45, and we multiply those guys out, and we see that we'll end up with 63.55, and chlorine is going to be 70.90. We go ahead and add those guys up to get our answer, and our answer is going to be 134.45, and we just change the units. It's now AMUs. Alright guys, we're going to go ahead and start working on number 38. But before we do that, I'm just going to go ahead and tell you that for your reward for watching the video, coming and doing the good work, if you watch the video, guys, you can go ahead, take a note card. Guys, this is very important. It's a 3x5 note card. It has to be a note card. It can't be a piece of paper in the shape of a note card. It has to be a 3x5 note card. And you can take a 3x5 note card and you may write whatever you want on that note card for the test. Whatever you want on there. If you want to write every single polyatomic, go ahead and do that. If you want to write all your Greek prefixes, do that. If you want to write the steps for finding the empirical formulas, the molecular formulas, the percent compositions, whatever you want to put on that note card, you can go ahead and put on the note card. The stipulations on it, and guys, I'm going to check them before the test. So the things that you have to have. It has to be a 3x5 note card. I don't want a piece of paper. Cannot be a piece of paper because I don't want people just to come to school and go, oh, hey, I found out about it. Now I'm just going to make one. Has to be a 3x5 note card. And the second thing is it has to be written. You can't print on it or type on it with a computer. It has to be in your handwriting. So 3x5 note card in your handwriting. You can put whatever you want on it for the test. All right, guys, let's go ahead and move on to number 38. Now, number 38 kind of builds on the previous question. It kind of builds what we were working on previously. And in the previous problem, we found the formula mass. And in this problem, it says, what is the percent composition of copper 2 chloride by mass? Now, to work this out, the first step of it, that if we were going to find any percent composition, is we would go ahead and have to find the formula mass. So we've already done that, so that's why I left the work up here. Now all we're going to do is just do the percent composition part. So after you find the formula mass or the molar mass, all you have to do is divide the parts by the whole. Now the parts are the purple part right here. The whole is the red part. So all we're going to do is just divide each of them by the whole. So 134.45 and divide 134.45, and that equals the percentage. Now the percentage for copper is going to be 47.27%, and we see that chlorine is going to be 52.73%. All right, guys, moving on to 39. On 39, it says determine the mass of, we see we have 0.24 moles of glucose. Okay, and it gives us glucose formula right there. So anytime we're going between mass and moles of mass, we need the molar mass. So we just start out and we have carbon and hydrogen and oxygen. And the first thing we're going to do is just find the molar mass. We have 6 carbons, 12 hydrogens, and 6 oxygens, and we're multiplying those guys by their atomic masses. Carbon is 12.01, hydrogen is 1.01, and oxygen is 16.00. Multiply those guys out, and we see that we have 72.06, we have 12.12, and we have oxygen is going to be 96.00. Add those guys up to get the molar mass, and we have 180.18 grams per mole. Now, that grams per mole means basically we have 180 grams of glucose, and it equals 1 mole of glucose. So we set up our boxes, and we have 0.24 moles, and that's of glucose. Just not going to write it. So we're going to go ahead and take this guy, and we have 1 mole. Mole's on the top, so mole goes on the bottom. And 180 grams, or 180.18 grams. Forgot the 18.18 up here. We go ahead and we multiply that out, and we'll multiply 0.24 times 180.18, all divided by the bottom, which is 1, and we'll get an answer of 43.24, and that's grams, and that's of glucose. Okay, moving on, it says 40, a sample of a compound contains 259.2 grams of fluorine and 40.08 grams of carbon. It says find the empirical formula. Now, to work this one out, we see we're going to have carbon and fluorine, and we go ahead and we just take their masses and we put them down, and we're going to have 40.8 grams of carbon and 259.2 grams of fluorine. And what we're going to do is we're going to divide, this is grams, so we're going to divide by the atomic mass on the periodic table to give us moles. So carbon is 12.01 and fluorine is 19.00. We go ahead and divide those guys out, and we'll get moles. And for this, we'll get, for fluorine, we get 13.64211. And for carbon, we get 3.39717. Now this is moles, and we take these moles and we divide by the smallest mole value, which is going to be carbon, and obviously we divide by itself, and we get 1, and then we divide fluorine's mole value, and we see that we get 4. And what this tells us is that our formula, we're going to have 1 carbon and we're going to have 4 fluorines. So we get carbon tetrafluoride. Now moving on to 41. 41 says the empirical formula of a compound is C2H5 and its formula mass is 58 AMUs. What is the molecular formula? Now we need 2 things to work a molecular formula problem. We need the empirical formula and we need the actual mass. The formula mass of 58 AMUs, that's our actual mass. So we go ahead and we set this up, and the first thing we have to do and we have to figure out is we have to figure out the molar mass of the C2H5. So we set it up, we have carbon, hydrogen, and we have 2 carbons, 5 hydrogens, and multiply them by their atomic mass on the periodic table, which 12.01 for carbon, 1.01 for hydrogen. And multiply those guys out, we'll get 24.02 and 5.05. And add those guys up to get our molar mass of the empirical formula, which is going to be 29.07. And we take this molar mass of the empirical formula and we divide it by the formula mass. So all we're going to do is we're going to take our 58 and divide it by 29.07, and we see that when we divide that on out, we're going to get a multiplier of 2. Now what this multiplier tells us to do is we multiply the subscripts in our empirical formula by 2 to get our answers. So our answer for this problem, our molecular formula, is going to be C4H10. Lastly, we see we have 42. Now in this problem it says a sample of a compound is 80% carbon and 20% hydrogen by mass. Its formula mass is going to be 30 AMUs, and says what is the molecular formula. Now to work a molecular formula problem we need 2 things. We need the formula mass, which is the actual mass, and then we need the empirical formula. It doesn't give us the empirical formula, but it does give us the percent composition, which we can find the empirical formula from the percent composition. So we go ahead and we have to work a percent composition problem to start off with. And we have carbon and we have hydrogen. And remember, first step, we change the percents into grams. So we are going to have 80 grams of carbon and 20 grams of hydrogen. We're assuming that there's a 100-gram sample. And then we divide that and go ahead and divide it by their atomic masses. And we're doing this dividing by the atomic mass or their molar mass to get the molar value. So we get 12.01 and 1.01. And we go ahead and we divide those guys out. And we see that for hydrogen we are going to get 19.80198. And try to keep a lot of decimal places, it usually helps. And then for carbon we have 6.661116. And what we do is, now that we have their molar values, we go ahead and we divide by their molar values. So we're going to divide by the smaller number, and obviously that is 6.66116. Okay, and we go ahead and divide that out. We see that dividing by itself, we automatically get 1. And then we divide 19 by that, and we see that we are going to get 3. Now, this 1 and 3 tells us our empirical formula. Our empirical formula is going to be CH3. Now that we have our empirical formula, we can now calculate the mass of the empirical formula to compare to the formula mass of the entire compound. So we set that up, and we're finding the molar mass of the empirical formula. We have carbon and hydrogen. 1 carbon, 3 hydrogens, and we're just multiplying those by their atomic masses, 12.01 and 1.01, to give us a total of add them together, and you see we're going to have 15.04. So we take this, and this is our molar mass of the empirical formula, this 15.04. Compare it to the formula mass, which is 30 AMUs. So we'll have 30 all divided by 15.04, which will give us a multiplier of 2. And this multiplier, remember, we multiply by the subscripts in the empirical formula. So our molecular formula for this compound is going to be our C2H6. Alright guys, that is it for the review. Make sure you study hard. If you have any more questions, go back and look at the PowerPoints or the practice problems on the wiki.